Let's practice some of the questions here on the pH and the POH. We have to calculate here the pH and the POH of the following solutions over here. We can calculate the pH from here, from this equation, if you know the H plus ion concentration. Similarly, we can find the POH from the hydroxide ion concentration. Now you look at here in the question, we are given the hydroxide ion concentrations for this solution A. Therefore, we can find it is POH. Okay, so the POH will be negative log of the 10 to the power negative 3, which will be 3, right? So you can see the POH over here is 3. And we also know that the pH and the POH, pH plus POH is equal to 14. So we have calculated the pH of a solution, so therefore the pH of this solution will then be, the pH here will be 14 minus the pH, right? Minus the pH, and the pH we just calculated is 3, so that means the pH will be 14 minus 3, that is 11, correct? So this solution has a pH of 3 and the pH of 11. So what about the solution B? Again, we know the concentration of hydroxide ions here, so that means we can again use this POH formula here. The POH will be equal to negative log of the 1, right? Negative log of 1.0, which is equal to 0, correct? So that means the POH for this solution is 0, and therefore the pH for the solution will be 11, 14 minus 0, which is 14. Correct? So you can say this solution has a pH of 14 and the POH of 0, right? Or you can alternatively, you can also solve these questions from by calculating here this the hydrogen ion concentration. Now you can also directly find the pH, right? Suppose we know the hydroxide ion concentration, that is 10 to the power minus 3. So we know that dissociation constant of the water, the dissociation constant of the water is actually the H plus ion concentration times the hydroxide ion concentration. Now when you know the hydroxide ion concentration, you can say that the H plus ion concentration will be, H plus ion concentration will be the dissociation constant of the water by the hydroxide ion concentration, right? Which is 1.0 into 10 power minus 14, the dissociation constant of the water, by the 10 to the power negative 3, right? This will give us the hydrogen ion concentration. So you can say the hydrogen ion concentration here will be 10 to the power negative 11, and therefore you can find the pH directly. The pH now here will be, the pH will be negative log of the 10 to the power minus 11, so it will be the 11, the pH is 11. So you got again the same. So what is the pH of the following solutions? We have a 0.001 molar HCl solution. So that means in this solution, HCl we know dissociates into H plus ions and the Cl negative ions, right? So this H plus ion concentration will be the same, this one, right? So H plus ion concentration over here is actually 10 to the power negative 4, right? So therefore you can say the pH for this solution will be a negative log of the 10 to the power minus 4, which is 4, right? And what about this solution? We have a sodium hydroxide, and this sodium hydroxide is base, and we can calculate the hydroxide ion concentration from here. The hydroxide ion concentration in this case will be again the same, this one, which is I think this is 10 to the power minus 5 here, correct? This is 10 to the power minus 5. So therefore from this one you can calculate for the pH, which will be negative log of the 10 power minus 5, which is 5, right? Therefore the pH for this solution will be, it will be 14 minus 5, right? pH will be POH minus the 14 minus the pH, correct? So that is 9 here, right? So that means this will be the pH of a solution here. Or you can first alternately you can first find the hydrogen ion concentration, right? The hydrogen ion concentration over here we can calculate from the dissociation constant of the water, which is H plus ion concentration times with the hydroxide ion concentration, right? And therefore the H plus ion concentration will be equal to 1.0 into 10 power minus 14 by the hydroxide ion concentration, which is here 10 to the power minus 5. So again you get the same answer. I think the H plus ion concentration here will be 10 to the power minus 9. That is the hydrogen ion concentration. So therefore you can find the pH, that is negative log of the 10 plus 10 power minus 9, which is 9. So you again got the same. Now look at the sulfuric acid. Its molarity is 0.001. Okay, 0.001 mole of H2SO4. But look at the H2SO4. 1 mole of an H2SO4 produces basically 2 moles of the H plus ions and 1 mole of a sulfate ion. So here in this case, what will be the H plus ion concentration? See, H plus ion concentration will actually be, that will be 2 times the molarity, right? Isn't it? Because 1 mole of H2SO4 produces 2 moles of H plus ion. So that means the H plus ion concentration will be 2 times the 0.0001, which is, you can also write it 2 into 10 to the power minus 4. That is the concentration of the H plus ions. And you can find the pH now, which is, negative log of the 2 times the 10 to the power minus 4. When you simplify this one, it will be about, it will be 3.7, right? It is 3.07. So that means this solution has a pH of 3.7. Hope you got it. Thanks for watching the video. Bye for now.